and welcome to College Algebra 5.5. It's all about modeling exponential and logarithmic equations. So what I would be cognizant of are the generalized models here. So for a growth model, y equals ae to the power of bx. For a decay model, y equals ae to the power of negative bx. In logistic, y equals a over 1 plus be to the negative rx. In a logarithmic, y equals a plus b natural log of x, or y equals a plus b log of x. Now, in general, we're going to focus more on the exponential growth and decays. So if I get a problem like this, in a research experiment, a population of fruit flies is increasing according to the law of exponential growth. So I know I'm going to use a growth model. After 2 days, there are 100 flies. After 4 days, there are 300 flies. Write an exponential model. So I'm going to write it in the equation structure of y equals a e to the bx. So I have to figure out what my a and b are. Well, usually you need at least two coordinates. So here I have the coordinate to 100 as well as the coordinate for 300. Well, both of these are x and y values. In fact, I can probably just write this in a different color to keep it more clear. So I can plug those in for x and y as separate equations. So we get 100 equals a e to the b times 2, or 2b, 2 going in for that x, and order doesn't matter in multiplication, and 300 equals a e to the 4b. Well, I now still have two variables to solve for. A and b are still variables. Remember that e is not a variable because functionally e is a number. Well, in order to solve two variables, I need at least two equations, which, funnily enough, I have. So here, I'm going to use the matter of substitution. Substitution is often dictated by getting one variable isolated. In the context of these, a is often going to be easier to get by itself. So if I'm looking at my red equation here, I can divide both sides by e to the 2b. So I get 100 over e to the 2b equals a. Now that I have a by itself, I can take this entire piece and replace this a in the blue equation. So now we have 300 equals 100 over e to the power of 2b times e to the 4b. Well, I'm multiplying by e to the 4b, so that's functionally going to go on top. And now I have e to the 4b over e to the 2b, which dictates that I would just subtract their exponents. So this all turns into 300 equals 100 times e to the 2b. Well, if I divide by 100, divide by 100, we get 3 equals e to the 2b. To get rid of an e, we can natural log both sides. So we get natural log of 3 equals 2b. Therefore, b equals the natural log of 3 divided by 2. You could type that in your calculator. So natural log of 3 divide, wrong button. Natural log of 3 divide by 2. Oh, you got to close your parentheses, though. Don't forget that step. And you could put this decimal. I'm just going to leave it as exact values. I think it's easier to work with. So I, of course, need to take this value and plug it in to one of these equations. It doesn't matter which. For the sake of argument, I'm going to plug it in for that one because I need to figure out an a value. So we get a equals 100 over e to the power of 2 times natural log of 3 over 2. Well, these 2's are going to cancel, so I get e to the natural log of 3. Well, funnily enough, e and natural log undo each other, so e to the natural log of 3 just gives me 3. So this means a has to equal 100 over 3. So now that I have A and B, my equation, or my answer, is going to be y equals 100 over 3 times e to the natural log of 3 over 2 times x. And then here it says how many fruit flies are there after 5 days. I'm just going to plug in 5 for x into my equation that we just created. So for y equals 100 over 3 e to the, we have a fraction, alpha there. We get natural log of 3 over 2 times 5. And we get about 519.6, so I'd say about 520 flies. And then here, how long does it take the population to reach 10,000? 10,000 would be the y value. So plugging in that 10,000 for y, and just solving for x, I can multiply both sides by 3 over 100 to get rid of that 100 over 3. I get 300. To get rid of this e, we can natural log both sides. So now we get the natural log of 300 equals the natural log of 3 over 2 times x. Well, I can multiply both sides by 2 to get rid of that 2 and divide by the natural log of 3, just like multiplying by 100 over 3 over 100 to cancel out the 100 over 3. So we get that x equals 2 natural log 300 divided by natural log of 3, which I can type all right into my calculator. And we get about 10.4 days. 10.4 for these in a matter of days. Thank you for listening, and I hope you have a great day.